Good afternoon. And this is the last section for UEFI TechCon. So, but yeah, you know, Arm again. So the good thing is that this is the last one. So we already have 3 Arm sections. So that means I can skip some of my slides to shorten this presentation. So you can have a networking time earlier. Yeah. So yeah, I'm tech lead for the SystemReady program from Arm. Yep, this is me. And yeah, this is a section presented by my line manager and my colleagues earlier today. So yeah, before we begin, I still want to walk through the agenda. We will start with the why we need the Arm SystemReady and the challenges we run into before and why we have our Arm SystemReady. And the second one would be what is Arm SystemReady and what is our test suite for you to use to use that in your product, yeah, and how we can integrate our SystemReady test suite and self-declared compliance into your product. All right, so why? Yeah, the main problem is generic OS boot install and run. Maybe I think it's 15 years ago, for Arm ecosystem, there was no, I think there was no generic OS support, and because I think Arm ecosystem is mainly for the cell phone and the embedded system. So that means at that moment, when people try to use the OS boot, generic OSs, they will run into so many problems like Linux kernel panic, or if you run the Windows, will run into the BSOD or system freeze. And oh, by the way, generic OS here means that you download the OS image from OS vendor and directly download that from OS vendor's website and directly use that without any modification. So that kind of OS image, basically they expect the platform to comply with the industry standards like UEFI, ACPI, SMBIOS, without any vendor-specific workaround. So when people run into this kind of issues, they will, if they want to debug this kind of issue and prevent this kind of issue happening, they will need to try to understand, to read through all the specs that are related to OS boot and the install. So that including the industry standard firmware spec or Arm firmware spec, even and the Arm and the industry standard hardware specs, even the documents from the OS vendors. And for different OS operating system, you may also need to learn different kind of type of debug tools. So that is kind of, for a person who newly joined the Arm ecosystem, that it would be quite hard to get their system successfully boot and install the operating system, right? So we solved the problem. So Arm developed some specs that I think my colleagues also already mentioned, like BSA, SBSA for hardware requirement, and SBBR for firmware, and BBSR for a security one. So we, based on that specs, we this kind of spec contain only the requirements from industry standard and Arm standard that are necessary for a generic OS install and boot. So that means that for Arm, if you want your system seamlessly support the generic OSs, you can only check that full specs instead of the one I mentioned in last slide, so many specs. So that can save your time a lot. Yes. So, and then besides, in addition to that spec, we also provide our test suite. So you can easily use our test suite to run our test suite instead of to learn a lot of skill to debug your issue. So because after you run our test suite, we will generate a repo and the logs, so you can easily know what is wrong with your implementation and to debug the issue. Yep. All right. So I think this one don't already mention that, so I won't say this the same. So basic. Okay, this is Dong also has a better block diagram. So yeah, this one the same. So BBR. Basically, for my version, old version, actually, our BBR required list all these interfaces for supporting the up layer operating system. So in practical way to describe that, that means you need to implement 1, 2, 3 SMBIOS, ACPI, and the UEFI interfaces in your UEFI firmware. That could be just like Don mentioned, it can be EDK2, can be Cobalt, can be any different firmware implementation. And you need to implement your the SMCCC, PSCI, SDEI interfaces in your trusted firmware for supporting the generic OS. Yep. So besides the system architecture specs, we also have a spec for our partners to declare their compliance, the system level compliance. Yeah, this was the begin with the certification because 15 years ago, probably there was also no OS certification and silicon providers certification. So at the later moment, we created a certification program, and so that that's kind of like putting all the things together to let our partners show their system can seamlessly work with the generic OSs, and then so this spec is the way for you to know if your system really meet that requirements can be work properly with the generic operating system. So for system ready band, here I only talk about system ready band because this is a system ready band presentation. So we have two sets of requirements. If your system is a server system, your implementation need to comply with the BSA, BBR, SBSA, and the BBSR. However, if your system is not a server, you don't have to. Of course, you don't have to comply with the server supplement hardware requirement one. That's SBSA and the security one. So we have two different sets of compliance requirement for you to use. All right. So then our tool. Yeah, this is our tool. I think another colleague mentioned that. ACS, Ide mentioned that. So in short, this is our test suite, and we have 4 main tools: UEFI, CT, FWTS. Both of them also use the x86 system for validate UEFI, ACPI, and SMBIOS. And then for ARM, we further improve. No, not improve. We add some test cases to also cover the SMCCC and the PSCI, the ARM Pacific firmware interfaces requirements. So we also use that to validate the firmware implementation, and we also have our own BSA and BSA and SBSA UEFI application and the Linux module to validate hardware requirements. So that's our main that's our main 4 tools in our live image. I mean test suite image. Yes. So this is details about what the firmware. Yeah, in this section, actually, I just want to say the key point here is that in this section, I will talk about not only, actually 4 of these can validate the firmware interfaces. Even these 2 are mainly for hardware. I will talk about this more later. So that's the first one. The firmware interface is validated by our SBBR UEFI as CT. are list interfaces. So including the boot service test and runtime service test and the low image and so on. So for Arm SystemReady, we use SCT to mainly validate the UEFI firmware interfaces. And for FWTS, Arm SystemReady FWTS, we mainly use that to validate not only these two, ACPI and SMBIOS, but also SMCCC and PSCI. And okay, this is something different from my colleagues. Yeah. So for BSA and SBSA, although they are hardware requirement tests, but our test case actually use the same way to access the hardware through the ACPI table, even the UEFI service. So if your ACPI table or UEFI services has some issue, implementation issue, that means that our test will also report the failures. So that means that our BSA and SBSA test can indirectly also validate your firmware implementation. So this is the details. For example, our SMBIOS test can also validate your IORT implementation, and our UR test can also validate your SPCR implementation. This is not like FWTS to just check the format, the field, define the field in ACPI table. This is like the value you report in the ACPI table will really be used to access your hardware. So that can really validate your firmware implementation. Yeah. So this is another page talking about our BSA and SBSA test to validate your not only your ACPI table. For PCIe, we also use the protocol, PCIO protocol to validate the implementation. Yep. Okay, so I still want to go through the how we use our tool. So it's that you just need to go to this link. It's our SystemReady ACS GitHub, and to download a preview image that is .img file, and then write that .img file. Use the tool like this one, Rufus on Windows OS or DD command from Linux OS, and write that to your media device like NVMe drive or external USB drive. After that, the drive will become this one. Yeah. So you will have a tool in this folder, and but after you run the test, all the result will be created in this folder, ACS result folder. So, yep. Okay. Then when you generate that ACS media device, you just need to insert to your system and then put to the boot order to move that boot option to the top of boot order so that it can finish the automation, because the automation test will reboot system several times. So we want that media device being loaded after reboot. So you need to change the boot order. So after that was just like this one. Started with this grab menu and automatically launched the second option, automation, SystemReady band ACS automation, and started with the SCT, and then BSA, SBSA UEFI, and then boot Linux OS, and then run the FWTS and the Linux BSA and the SBSA, and then it will show the result, brief result for you. Yeah. Okay, and this one is just more references here. So you can, let's say, if you run our tool, and then it report the failures, and where will be the solution, where will be the fix. The good thing is there are already many reference on the internet, open platforms, and even closed one like Grace, NVIDIA Grace or Ampere Ultra. They also publish their firmware source code on their GitHub repo, so you can also check their implementation. And for the open platform like our FVP and 6P1 system, that is the Rexa Orion 06. These two systems, they also publish their firmware, so you can build your own firmware on their system. I mean, update your firmware on the system to give that a try. And also Raspberry Pi is also open platform and open source firmware. Yes, you can try that. Okay, it's integrate. So just like Dom mentioned earlier, now our program, SystemReady program, change our working model from certification to a self-compliance. So now I think our strategy or policy has been changed to work with our partner to integrate our compliance testing into their production process or their certification. So here you have two ways if you want to integrate that our test suite into your process. There are two ways to do that. The first one would be just like automate the manual process I just mentioned. You just write a script to download the image and unzip that image and write that image to your to media device and run some command to change the border and then reboot the system. Then you will get the same result. And then, or you can go with the method too to integrate individual test suite like BSA, SBSA, FWTS, and SCT individually integrate them into your test process. Yeah, this is the details about what commands you can use for the method one if you are using a Linux OS. Yeah. And this is the details about how you can go with the method two. And NVIDIA, we are working with NVIDIA. They are using the method two. So I think it's the most recent release. You will see the NV and SVT include our test tools, BSA, SBSA, and FWTS and SCT. And the only thing missing now, I think, is the Linux BSA and the SBSA. And we are still working with them, so probably next release they will cover all of them. Their test tool will cover all of our tools. Yeah, so this another thing. Okay, so if you run that our test suite and the result is good, you can also you can do it self-declare compliance by two ways. The first one would be like you add in your product spec, like this one, the bottom screenshot. In your product spec, there may be a section called industry standard compliance or a feature, and there may be something like ACPI compliant or PCI compliant. You just need to add one more line saying SystemReady Ben 3.0 compliant. Yeah, just do one more line to do this self-declare compliance. Or in your blog or press release saying your company announced that your device has achieved compliance with the SystemReady Ben 3.0. All right. Oh, this is something, we mentioned earlier. Yeah, just like previously, some partners certification were based on SystemReady certification now, but however now we change it to self-compliance. So we are still working with them to shift the basis to the self-declare compliance under the SystemReady ban. And Red Hat already did that. They already published a document article saying the the Ray requires system that meets the Arm SystemReady band specifications. So, yep, this is something in progress or already happened. Okay, so ongoing one, yeah, the first one is working with NVIDIA, and the second one is the OS vendor one, and the third one is some ODM OEM also working with us to integrate integrate our test suite into their release processing. Summary. Oh, summary is, yeah. By integrating our tests, you can get the benefits like this one: improve your quality, reduce the development time for the OS enablement and debugging, and also for the silicon providers and the OS vendors certification. And then is the you also can declare your system is compliant with the system ready. Yeah. Okay. Call to action. Integrate. Share your broker if you try to integrate that and run into any problem, just come to me and I will be very happy to fix the issue for you and contribute back. If you see any issue with our even spec or test suite, yeah, just also come to us and we will fix the issue for you. Yay. All right. Question. Yay. Oh, yeah. All right. Hey, hi, Tom.
I got the microphone from one of the slides you just supported Arm.com email there. You send an email to that, I'll send you straight to Sonic.
Okay. All right, but I don't have that. Yeah. All right. Yeah.
All right, thank you so much, Lenny.